Hello everyone, my name is Prabhakar Guho and I'm going to present a short video on various concepts of data mining using SAS Enterprise Miner. For this video, I'm using this database, which is the banknote authentication database. This data is basically were extracted from images that were taken from genuine and forged banknote like specimens. For digitization, an industrial camera was used for print inspection, and from that image, various parameters like variance, skewness, kurtosis, entropy are measured, and this is the class which will basically identify whether the image is a forged banknote or a real banknote or a genuine banknote. So 0 represents forged banknote and 1 represents real or genuine banknotes. So the first concept which we are going to learn is overfitting. So here we have two decision trees which has different maximum depth. The first decision tree has maximum depth of 3, and the second decision tree is having the maximum depth of 6. And then we are going to compare both the decision tree using model comparison, and let's run the model comparison. Let's see the results of the model comparison. As we can see, the misclassification rate and sum of squared error decreases as the maximum depth increases. Thus, the maximum depth of 6 tree is better than the maximum depth of 3 tree. However, if we increase the maximum depth, this will result in overfitting, and thus we cannot use the model for any other dataset. So the next concept which we will be talking about is splitting rules. So in decision tree model, we have various certain criteria which is used to split the parent nodes into its subsequent child nodes, and this criteria is actually is implemented using certain rules. The default rule which is used is chi-square, and we will be looking into the results of it. So we have got the results. Let's look at the results now. So we can see the result has come up for the chi-square rule, and the misclassification rate is 48% for test. Let's use this decision tree to change the splitting rule to entropy rather than chi-square. So entropy is the measurement of the disorder of a system. In decision tree, it is actually the measurement of an impurity of a node. It will determine the information gain that we will get when a split occurs based on a single attribute. So what we will do is we will compare both the model. Decision tree 1 has the nominal target criterion as chi-square, and the decision 2 has nominal target criterion as entropy. So we will run the model comparison now. So let's look at the results now. As we can see in the results, the decision tree with the splitting rules as entropy has less misclassification rate. If we can go and check the misclassification rate of test, we can see that the decision tree which has splitting rules as entropy has less misclassification rate. So we conclude that the decision tree with splitting rules as entropy is better than the splitting rules with chi-square. So the next concept which we are going to learn is data partition. So we have basically used two different decision tree to find out which data partition will be better. So here we have one data partition where we have partitioned the data with 40% as training, validation as 30, and test as 30%. And the other data partition which we have done is 20% as training, validation as 30%, and test as 50%. And we are both the data partition are sent to decision tree, and then we are comparing both the models, and after comparing we are getting the misclassification rate is basically less in the decision tree where the training data is higher. We can also see the lift has changed a bit in both the decision tree. So we can conclude that the decision tree which has higher training set is better than the decision tree with lower training set. So the next concept we will be learning is about clustering. So we will be seeing how the number of clusters in a clustering impacts the mean square error. So by default, when we give it automatic, the maximum number of clusters in SAS is given as 10. We will be changing it to user specify, and let's see if when the number of clusters is 5, what will be the result. We can see the root mean square error is somewhere between 0.59 to 0.55. Let's now go and change the number of clusters and increase it to 10, and let's run the clustering algorithm again, and let's see the results now. So as we can see, now the mean square error is has a range of 0.38 to 0.35, and it has decreased dramatically from the previous example, which has a number of clusters as 5. So the next concept which we will learn is about k-fold cross validation. So here the complete data is divided into k equal parts, and then each part is taken as a test set and the remaining parts are taken as training set, and then it will be the same data will be run in the model for k times and in each time the test data will be different. So here we have a picture of how a 5-fold cross validation will look like. So as we can see, in each fold the test data is different, and then finally all the data all the prediction error of the datas of the models will be averaged, and a prediction statistics will be the result. So let's see this concept in SAS Enterprise Miner. Here we have taken a simple decision tree, and what we will do is we will use cross validation to build a model. So what we have to do is we have to enable cross validation here. So as we can see that we have enabled we have used perform cross validation as yes, and then we will run the decision tree. Let's look at the results now. So this is the decision tree which has been made by our cross validation, and so cross validation is basically used when you have less amount of data and there is a chance of overfitting. At that point of time we use k-fold cross validation. Thank you.